Hey, I wanted to make a quick little video, this is Moser, on number 8 in the chapter review, because it's something that a lot of people seem to need a little help getting over the hump with. So what I've got here are two representations of a fluorine atom. And of course, you know, it's starting off with 9 protons and 9 electrons. So it's got a full first main energy level. That's the first shell, and that's got 2 electrons on it. And then on the second main energy level, it's got 2, 4, 6, 7, bringing us to that total of 9. So it's got 7 valence electrons. And we can show this in orbital notation like this, where we show each orbital, 1s is full, 2s is full, 2px and y are full, and 2pz has got 1 unpaired electron. Well, the question in the book asks you to show, and I think it's chlorine, but this is the same idea, show the bonding of a Cl2 molecule using orbital notation. So I'm going to demonstrate this for you with fluorine and then let you figure out how to apply it to chlorine. If we have these 2 fluorine atoms and they get to the point where their orbitals are overlapping and they can share that middle set of electrons, now they both feel like they've got a full octet on their uppermost main occupied energy level. So it's easier to visualize the actual bonding that way, but we can show that using orbital notation if we sort of stack these on top of one another, and then we take the 2 orbitals that are each sitting there with only 1 electron in them, and we loop them together to indicate how we're sharing electrons in this case. We can also do this with 2 atoms that aren't identical. So here's hydrogen and fluorine. Notice that hydrogen has got 1 lonely valence electron. Fluorine, of course, has its 7. We can bring this over until it's lined up and sharing. Those are awfully close, but it's just badly drawn, I guess. There we go, like that. And we can demonstrate this doing the same thing, lining up those orbitals that only have a single electron and then circling them to show them overlapping and linking. That is how we would show the bonding of hydrogen fluoride in orbital notation. That's it.